Hello and welcome to another video. Today in this video we're going to be talking about the Cape Sandbox. Cape Sandbox is open source software for automating analysis of suspicious files. So this video playlist is about malware analysis, and it's part of the training that I'm doing with O'Reilly on AI malware analysis. In that training I have one segment 5, where I'm going to be talking about sandboxes. So I'm going to cover Cuckoo Sandbox, Vectra Sandbox, and Cape Sandbox. Probably, if you haven't subscribed already, probably you're going to miss this one because the video is going to come out after the actual training with O'Reilly. But I have other courses. So I have on the 10th of February, I have a course on quantum AI and cybersecurity. So if you're interested in this kind of content, check with your company if you have O'Reilly subscription, which is also Pearson. I was surprised when I found out that University of Oxford, where I work, had a full subscription to the O'Reilly Digital Library. A little bit about myself. I work for the University of Oxford, and I'm going to show you my profile over there. But if you wanted to check the type of publications that I work on, so here I have some open access publications. Actually, on Google Scholar, everything that you're going to find here, it's all fully open access. All of those are free for reading. If you click on that link, it's going to open the actual research paper. It's not going to lead to a journal and ask you to subscribe to the journal. University of Oxford has paid the open access fees, which is around £3,000 per journal paper. That's why they're free to use. Now, let's see a little bit about myself. That's me. I work for the University of Oxford Department of Computer Science. I need to update this profile, but here you can find a lot of information about me. I also have a LinkedIn profile, so you can join me over there, and I can, if you click that you want to follow me, usually I would respond that I would accept. I don't really have many people on LinkedIn. So Cape Sandbox, what we're going to talk about Cape Sandbox. We're going to talk about how you can use Cape Sandbox for AI malware analysis and enhanced threat detection. Those are the two things. And what do I have for the Cape Sandbox? I have this whiteboard. So this is the copy of it. I'm going to use the original is this one. I'm going to use that for the tutorial. This is a copy. And I'm going to do drawing in preparation for the tutorial, and then I'm going to stop the video, upload, and this is going to be the last video of the series for today because it's getting late. It's gone past 8 p.m. It's 2nd of January, just after the New Year. So that's enough. Now I'm moving on to my iPad to record the second part on the whiteboard. Let's see. Now you should be seeing the whiteboard. Cape Sandbox. Let's open this. And what we're going to talk about Cape Sandbox. Well, let's start from, hold on, let's change that into something more, even more maybe. Okay. So this is, we're going to talk about AI malware analysis. And what is Cape Sandbox? It's a platform for malware analysis. And this platform is focused on adaptability for analyzing AI-powered threats and complex polymorphic malware. So that's what we're going to talk about, how you can adapt this sandbox for analyzing AI-powered threats and very complicated polymorphic malware. For that, you can use dynamic execution environments and integration with artificial intelligence frameworks. And Cape Sandbox facilitates both of those. So it facilitates behavioral and static analysis, so dynamic and static analysis. And that makes it a good tool for AI malware analysis. And now we're going to have a whole step-by-step explanation of the process on how you can apply the Cape Sandbox for this specific type of analysis. We're going to talk about the core functionalities, the setup process, and we're going to talk about the workflows for detecting and mitigating advanced threats. Starting from the first step, understanding the Cape Sandbox. It builds on its predecessor, so it integrates advanced dynamic analysis capabilities and includes it includes tailored environments for AI-based threats. So this, you can get a more detailed insights on the behavior of malware samples. So you can focus on the host systems, APIs, on the network instruments. But let's look at these specific steps one by one. So first, you can apply the Cape Sandbox for dynamic malware execution. So you can execute malware in a controlled sandboxed environment, and then you can capture the real-time behavior. So this is essential for AI malware analysis. Then second step, in the second step, you can, for AI enhanced pattern recognition, you can use machine learning models to detect evasive behaviors, such as visualization aware and sandbox detecting malware. Third, you can analyze polymorphic code. You can track malware mutations during executions, and this would provide insights into their adaptive capabilities. Fourth step, you can integrate threats into the feed. So this step supports the correlation with external intelligence feeds for faster identification of known threats. And the fifth step, you can apply modular and extensible design. So the Cape Sandbox can offer customizable configurations, which would allow you to analyze unique environments and to stimulate those in unique environments. So that's the first step. And then how do you use the Cape Sandbox? So here we're going to focus more on how as opposed to defining why. First step, you need to have environmental configuration. You need to set up the Cape Sandbox to simulate the target environment where the malware is likely to operate. And why is this important? Because customized environments, they usually mimic real-world scenarios, and this increases the accuracy of the behavioral analysis. How to complete this? First step, you would configure a virtual machine with specific operating systems and software stacks. So for example, Windows 10 with vulnerable Office versions. Then you would enable, second step, you would enable the network emulators to stimulate internet connectivity and command and control channels, usually written as C2. And third, you would install Cape Sandbox agent on the virtual machine for comprehensive monitoring of the system call. You can also monitor file activity and network interactions. So those are the three steps that you need to perform to configure the environment. Now this one, it's a little bit more complicated step. So here we're going to have a look at some of the code that you need to apply. And you need to submit malware samples. What's the objective of submitting malware samples? Well, you need to upload AI-powered or polymorphic malware samples to the sandbox because you need to enable real-time observation of how malware executes and how it interacts with the environment. So how to complete this? First step would be, so this is how you would navigate to the Cape Sandbox web interface, or you can use the RESTful API for automation. Second, you can submit the sample with custom parameters such as execution timeout. You can enable memory dumps. You can monitor API calls. And example of API submission would be here. So you would have bash, and then the first line would authorize the second, the beaver key. So that's the simple code that you will need to run to upload the polymorphic malware with the API submission. And then to analyze the dynamic behavior, what's the objective of analyzing dynamic behavior? What do you need to do that? Well, you need to observe the runtime behavior of the malware. So if it's a polymorphic malware, static analysis is not going to help much. And why is this important? Because it would help with identifying specific actions the malware performs, such as the file encryption, the data exfiltration, or the command and control communications. Now, more importantly is how to complete that step. First, you would monitor the process tree to identify spout processes, spawned processes and injected libraries. Second, you would examine the registry modifications, the file manipulation, and the API calls. Third, you would detect network activity using DNS queries and HTTP or HTTPS connections. This is an example insight. So you would look at the network traffic for suspicious domains, and you can look at the file encryption patterns, which usually can indicate ransomware. Now, looking at the step number 4 here, polymorphic behavioral tracking. What's the objective of polymorphic behavioral tracking? Is to analyze how polymorphic malware adapts its structure and behavior during execution. And here this unveils hidden capabilities and can reveal how the malware attempts to evade detection. Now, most important, how do you do that with Cape Sandbox? Well, you can use the Cape Sandbox memory dump feature to capture runtime memory states. You can apply AI-based detection models to analyze changes in the malware code across the iterations. And third, you can focus on identifying invariant logic elements that remain consistent despite obfuscation. Now, moving on to step number 5, I believe this is 5, yeah. How do you apply the threat intelligence? Well, and why? What would be the objective? Well, the objective is to correlate behavioral data with external threat intelligence feeds. And why is this important? It's important because it enhances detection accuracy by linking malware behavior to known campaigns of threat. And then how do you achieve that? How do you complete this step? First, you need to integrate Cape Sandbox with platforms like VirusTotal or MISP. MISP stands for Malware Information Sharing Platforms. Then you need to query the IOCs, the indicators of compromise, which are extracted from the malware. Then you need to automate the alerts for future detection of similar patterns. And step number 6 would be automating the detection rules. And the objective here is to identify, to develop more detection rules to identify similar malware strains. So you need to develop detection rules. Why is this important? Because you need to streamline the future threats detection, and you need to improve the incident response rates. How to complete this? Well, those would be the steps that you need to perform. So this is how. You need to use Cape Sandbox built-in rule editor to create Yara rules based on the malware unique behavioral traits. Second, you need to test the rules against known benign samples to minimize false positives. And you need to deploy the rules to endpoint security tools and CM systems. Now, this is the final slide here. I believe it is. Yes, it is. It's the final slide. What are the unique capabilities of Cape Sandbox for AI malware detection? Well, the unique capabilities are that it supports AI-driven analysis models. So you can use natural language processing and graph neural networks. You can use both to detect advanced malware behaviors, and it's trained on datasets comprising millions of malware samples and behavioral logs. So that is point number 1. Point number 2, evasion-aware monitoring. Why is this specific Cape Sandbox relevant to AI malware analysis? Is that it can detect and counteract attempts by malware to identify sandbox environments. And then it employs a randomized system configuration to prevent fingerprinting. The third reason is that you can perform multi-stage analysis, so you can analyze malware within multi-stage payloads. You can capture each stage unique behavior. And second, you can track the execution flow across multiple processes and network calls. And fourth reason is that it has extensive API capabilities. And those are, first, it enables integration with custom security workflows. And second, it provides granular control over analysis settings and report generation. Now, the conclusion on this specific Sandbox usage is that it's a good tool for analyzing and preventing AI-driven malware threats. It combines dynamic analysis, AI-enhanced threat detection, and it has quite an extensive architecture, which makes it good for modern threat intelligence operations. And you need to follow those steps that I outlined here in order to perform the malware analysis and to use the full potential of the complex malware strains. So you need to follow those steps each one by one, and then you can detect hidden behaviors, and based on those hidden behaviors you can adjust your defenses to evolving threats. And malware will continue to adapt to these capabilities, and CAPE Sandbox and other tools that I'm going to discuss in the next video, so will be increasingly critical in maintaining the cybersecurity posture. So hold on, how do I get out of here? Why is it not, okay, stop mirroring. Okay, there we are. So that is the end of this video. That's the CAPE Sandbox tool. It's open source. You can install it, but you need to set up a virtual environment first. Remember, you're going to be dealing with malware. Even if it's out of date, it doesn't matter. You still need to have a virtual environment. But that is a different tutorial. So this is not a tutorial on setting up virtual environments. I'm going to record those in the future. So nobody wants to listen to very long videos. I have to keep them short, less than half an hour. Actually, the ideal duration for a YouTube video is 5 minutes. Anything more than 5 minutes, people just don't watch. So that's why I don't want to record one long tutorial. Actually, this session that I'm recording tomorrow, this is going to be 4 hours. So that's going to be tomorrow evening. It's going to be quite an exhausting session. There's another one on February the 10th. And if you prefer more comprehensive setup that you cover everything, then you can subscribe to those. If you prefer shorter videos, you can subscribe to my YouTube channel. And here I would record the practice demos. So this is just in preparation for the actual video session tomorrow. That's why it's shorter. So I will see you in the next one.